In this section, we'll be going over the mathematical functionality provided by NumPy library. Let's start. We saw how we can create NumPy arrays from Python lists. However, NumPy also provides us some quicker ways of creating arrays. If you want to create an array pre-filled with all zeros, you can use the .zeros function. Let's see how it works. Let's create an array containing 10 zeros. We'll use the np.zeros function for it. Zeros array equals np.zeros 10. Print zeros array. Let's run this cell and see the output. We indeed get an array with 10 zeros, but they are floats. This is the default functionality of the .zeros function. Let's convert our array into integer. For this, we will use the .astype function. Zeros array equals zeros array .astype int print zeros array. Let's run this cell and you can see that our array now contains integer zeros. We also have a .ones function in NumPy which creates an array pre-filled with ones. Let's look at it. Let's create an array containing 10 ones. Ones array equals np.ones 10. Print ones array. Click run and we get an array containing 10 ones, each of which is a float. Let's convert this array into integer array. Ones array equals ones array .astype int. Print ones array. Run this cell, and here you go. Our array now has integer values. If you want to have an array pre-filled with some other numbers of your choice, you can use the .full function. This function takes two arguments. First argument is the number of elements that you want in your array. Second argument is the number to pre-fill the array. Let's create an array containing 10 elements, each of which is 5. Pre-filled array equals np.full 10-5. Print pre-filled array. Run this cell, and as you can see, we have an array containing 10 elements, each of which is 5. If you want to have a list pre-filled with floats, you will have to pass a float as the second argument. Quiz. Here is a quick question for you to think on. Let's have a look at some scalar operations with NumPy. We can add a scalar to our NumPy array using the plus operator. The scalar value will be added to each element of our array. Note that doing the same thing with Python lists throws an error as shown in the figure. That's why we prefer NumPy arrays in data science. Let's create a 2D array. Matrix equals np array (4-5-6). Print matrix. Let's run this cell. Now, let's add 2 to this array. print matrix plus 2, and run this cell. We see that each element of the array has been incremented by 2. Now, let's do the same with Python list. Python list equals 1-2-3, 4-5-6, print Python list plus 2. As soon as we run this cell, we get an error. We can subtract a scalar from one NumPy array using the minus operator. The scalar value will be subtracted from each element of your array. Note that doing the same with Python lists throws an error as shown in the figure. We have our Python list that we create in the previous example. Let's subtract 2 from it instead of adding. Print matrix minus 2 and run this cell. We see that each element of the array has been decremented by 2. Now, let's do the same with Python list. Print Python list minus 2. As soon as we run this cell, we get an error. We can also multiply an array with a scalar using the asterisk star operator. Again, each element of the array will be multiplied by that scalar. Note that multiplying a Python list with a scalar results in concatenation of the list with itself. We have our Python list that we create in the previous example. Let's multiply this array with 2. Print matrix star 2. Click run. We see that each element of the array has been doubled. Now, let's do the same with Python list. Python list equals 1-2-3, 4-5-6. Print Python star 2. We run this cell and the list has been concatenated with itself. Dividing an array with a scalar is also possible. Each element of the array will be divided by the scalar. We use single slash for float division and double slash for integers. Dividing a Python list with a scalar results in an error. We have our Python array that we created in the previous example. Let's divide it by 2. Print matrix slash 2 and run this cell. We see that each element of the array has been divided by 2 and the results are float. Let's try integer division. Print matrix double slash 2. Let's run this cell. We see that the resulting array contains integers. Now, let's do the same with the Python list. Python list equals 1-2-3, 4-5-6, print Python list /2. Let's run this cell, and here we go, we have an error. We can also raise each element of our array to some power using the double star operator. This is not possible for a Python list. We have our Python list of what we create in the previous example. Let's raise each element of this array to power 2. Print matrix double star 2 and run this cell. We see that each element of the array has been squared. Now, let's do the same with the Python list. print Python list $2. Let's run this cell and we can see the error again. Taking the transpose of a NumPy array is pretty simple. Just use .t after array to take its transpose. Note there is no built-in function for taking transpose of a Python list. Let's take the transpose of our array. Print matrix.t. Let's run this cell and we see the transpose of our array on screen. Now let's take the transpose of Python list. Print Python list.t. Let's run this cell and here we go, we have another error. Let's have a look at an element-wise operation between two arrays. An element-wise operation is an operation on individual elements of the array. First element-wise operation that we are going to talk about is addition. Two arrays can be added element-wise using the plus operator. Note that adding two Python lists using the plus operator results in their concatenation. Let's create two NumPy arrays. Matrix1 equals np.array 1-2-3-4-5. Print matrix. Let's run this cell. Let's create another NumPy array. Matrix2 equals np.array 1-2-3-4-5. Print matrix. Let's run this cell as well. Now, let's try adding these two arrays together. Print matrix1 plus matrix2. We run this cell and we get the sum of two arrays. Each element of first array has been added to this corresponding element of the second array. Let's try to add two Python lists. Print Python list 1 plus Python list 2. Click run and here you go, both the lists have been concatenated. Subtraction using minus is another element-wise operation. Note that two Python lists cannot be subtracted using minus operator. Doing this will give you an error. Let's subtract our two arrays that we created in previous example. Print matrix1 minus matrix2. We run this cell. The resultant array contains the difference of each element of first array with corresponding element of the second array. Let's try to subtract two Python lists. Print Python list 1 minus Python list 2. Click run and we get an error. We can also multiply two arrays element-wise using asterisk star operator. Doing these for Python lists will result in an error. Let's multiply our two arrays. Print matrix1 star matrix2. We run this cell. The resultant array contains the product of each element of first array with corresponding element of the second array. Let's try to multiply two Python lists. Python list 1 star Python list 2 print. We click run and get an error. We can also divide two NumPy arrays element-wise. We use single slash for float division and double slash for integers. Again, dividing two Python lists this way is not possible. Let's divide our two arrays. Print matrix1 dash matrix2. We run this cell and get the float division of two arrays. Let's also try double slash print matrix1 double forward slash matrix2. Run this cell and we have integers division of the two arrays. Let's try to divide two Python lists. Print Python list forward slash Python list 2. We click run and here we go, we get an error. We can also do matrix multiplication of two arrays using the built-in matmul function. Matrix multiplication in NumPy works the same way as in maths. We provide two arrays as an argument to the matmul function, and it returns us their matrix multiplication. Let's have a look at it in Jupyter Notebook. We have our two NumPy arrays called matrix1 and matrix2. Let's multiply them using matmul function. np.matmul matrix1-matrix2. Let's run this cell and we get the matrix multiplication of the two arrays. Also note, we did not use the print function in the last cell. Jupyter Notebook prints the result of an expression without the print function. In case of multiple expressions in a single cell, the last one will be printed. So, it is better to use print function when you need to print multiple things. Okay, here's a quick quiz question. Let's have a look at some of the frequently used statistical functions inside the NumPy library. The first one is min function, which gives us the minimal value of an array. Let's try this in Jupyter Notebook. We create an array. Matrix1 equals np array print matrix. Let's run this cell. Now let's use the np.min function to find the minimum value in our array. np.min matrix1. Let's run this cell. And we get 1 as output, which is indeed the minimum value in our array. .max gives us the maximum value in our array. Now let's use the np.max function to find the maximum value in our array. np.max matrix1. Let's run this cell and we get 6 as output, which is the maximum value in our array. .sum function gives us the sum of all the elements of the array. Let's use the np.sum function to find the sum of all the values of our array. np.sum matrix1. Click run. And we get 21, which is the sum of all the values of our array. .mean returns the mean of an array. Let's use the np.mean function to find the mean of our array. np.mean matrix1. Click run and the mean of our array is 3.5. .std is used to find the standard deviation of an array. Let's use the np.std function to find the standard deviation of our array. np.std matrix1. Click run and we found out that the standard deviation of our array is 1.707 825 127 659933. Median gives the median value of an array. We have covered only some of the statistical functions available in the NumPy library. Here are some additional resources for you along with advice. Never stop learning.